Space fans, and welcome to another edition of Space Fan News. Well, if the activity in my inbox is any indication, you guys want to talk about black holes. And not just any black holes, but the really big ones, ultra-massive black holes. Earlier this month, astronomers revised some mass estimates of a black hole at the center of the elliptical galaxy Holmberg 15A, also called Holm 15A, which is an enormous galaxy 700 million light years away that is home to the second largest black hole we've ever seen. Now, there is no doubt that black holes are fascinating objects. They are enigmatic points in space that contain boundaries that defy our observations. There are horizons close to these objects where we cannot hope to observe. The confines of physics prevents us from ever seeing inside. Now, these horizons are defined by the radius of the gravitational well, which is directly related to the mass. And it is by mass that we catalog black holes. They come in many sizes, from relatively tiny stellar-sized black holes, remnants of the deaths of massive stars, to objects billions of times the mass of our sun. Black holes get bigger by merging with other black holes, and astronomers believe that almost every galaxy in our universe has one at their centers. The roles black holes play in galaxy formation and evolution is not completely understood, but it is generally believed that as galaxies interact with one another through collisions and mergers, the central black holes also get bigger, and in some cases, much bigger. Which brings me to the galaxy Holmberg 15A, a member of the class of galaxies known as elliptical galaxies. And if you've ever seen my video on IC 1101, you know that these galaxies are not only the largest, but they are also the oldest. And they are named because of their shape, which has been sculpted by billions of years of interactions with other galaxies, each gravitational encounter smearing out any defined morphology it may once have had. And it leaves behind a blobby, roughly spherical shape. The color of these galaxies comes from the stars inside. They're almost all old stars. All the hot young blue stars in these galaxies have long since died, leaving only older, redder stars with lifetimes in the tens of billions of years. They contain very little gas for new stars to form as well, meaning that star formation has virtually stopped. About 60% of all galaxies of the universe are ellipticals. So Holmberg 15A is huge, old, and dying. And earlier this month, astronomers studying this galaxy have for the first time directly imaged the stars going around the black hole, Holmberg 15A star, using high-resolution, wide-field spectral observations on the MUSE instrument at the Very Large Telescope in Chile. And based on the motions of those stars, they calculated that Holm 15A star is 40 billion solar masses. Wow. Now, by comparison, Sagittarius A star, the black hole at the center of the Milky Way, is estimated to be only 4 million solar masses. So this one is a doozy. The Schwarzschild radius, also called the event horizon of this black hole, which is the point beyond which nothing can escape, is a whopping 790 astronomical units. That's way bigger than our solar system. By comparison, Pluto is on average only 39.5 AU away, and our heliopause, which is an ill-defined area where the solar wind no longer pushes against interstellar space, is around 123 astronomical units. So, having a 40 billion solar mass black hole with an event horizon reaching 790 AU out is pretty darn impressive. And this is probably among the first of this class of black hole that we'll measure, which they're calling ultra-massive black holes. Of course, because, that's how astronomers roll. We've got super, we've got ultra, then we'll have mega, no doubt, followed by ultra-mega, then super ultra-mega, and the list goes on. But even as big as this is, it still isn't the biggest black hole we know about. The biggest one is a black hole that may belong to the galaxy Tun 618, a distant, extremely luminous quasar that has a black hole 66 billion times the mass of the Sun. And the caveat here is this estimate comes from indirect observing methods of the galaxy itself, which aren't as accurate as measuring the individual stars that are in orbit around the black hole, like they did with Holm 15A star. So that number may have to be revised. Ton 16A shine with the luminosity of 140 trillion suns, and it gets its name from having been observed first at Tonantzinchia Observatory in Mexico. I did it on the first take. So right now, Holm 15A star is the most massive black hole measured using direct observations of stars in a galaxy 700 million light years away. And while I think all of that is amazing to think about, I mean, come on, a 40 billion solar mass black hole with a radius 790 AU out in a galaxy so old that the stars have long ago stopped forming, I mean, you gotta love it. But my favorite thing about this, it comes from all my years of working with telescopes. The fact that we can now directly measure the motions of individual stars in a crowded, somewhat dim galaxy 700 million light years away is stupendous. I mean, it's mind-boggling that we now have this kind of resolution. And it wasn't done in space, but on the ground, using equipment located under the Earth's blanket of air. Wow. Now, this technique involved measuring the motions of the stars going around Holm 15A star, then applying orbit-based axisymmetric Schwarzschild models to get to those paths to get the result that they obtained in this paper. I mean, amazing. The golden age, folks. What can I say? Well, that's it for this episode, space fans. Thank you, Deep Astronomy Patreon patrons, for your continued support. And thanks also to OPT Telescopes, a world leader in telescopes and accessories for amateurs and professional astronomers. And I want to thank all of you for watching. And as always, keep looking up.